All right, in section 4.4, we're continuing our discussion of what does the unit circle tell us? What information can we get from it? So yesterday we found these relationships in the unit circle. We said the sine of an angle can be found by looking at the y-coordinate of the point. The cosine of the angle is equal to the x-coordinate. And then we said the tangent is equal to the y divided by the x. We also said, by the way, tangent of theta is equal to sine theta over cosine theta. Okay. All right. So one thing I finished in our lesson with yesterday is that there is a lot of repetition in our unit circle. We have 5 numbers. They're just switched. The signs are changed. It's 5 numbers. So there's a lot of repetition. And so what I would like to do is summarize that into just 2 smaller graphics. So I'd like us to, well, you don't need to make the box. It's already there. But I've got this 3 by 3 box, and going down along the outside, let's do sine, cosine, then tangent. Across the top, I want to do pi over 6, pi over 4, pi over 3, which corresponds to, sorry I didn't leave enough room, 30 degrees, 45 degrees, and 60 degrees. Okay. Now, in our notes, in our last lesson, I said, what is the sine of every pi over 6 angle? So just kind of reference, the sine is the y-coordinate. And so we looked, here's my pi over 6 angles. The y-coordinate is 1/2, the y-coordinate is 1/2, the y-coordinate is negative 1/2, right? Regardless, the sine of any pi over 6 is positive or negative 1/2, okay? We could do the same thing for all of the angles. So the sine of any pi over 4 angle is radical 2 over 2, and the sine of any radical 3 angle is radical 3 over 2. Okay. We could do the same thing with cosine. The cosine of any pi over 6 angle is radical 3 over 2. Again, I'm getting this from the chart, right? Cosine is the x value. So I'm saying, what are the x coordinates of my pi over 6 angles? So here's my pi over 6. The x coordinate is radical 3 over 2, radical 3 over 2, radical 3 over 2, radical 3 over 2. So I'm just getting this from my chart. The x coordinate of any pi over 4 angle is radical 2 over 2, and the cosine of any pi over 3 angle is 1/2. And now let's talk about tangent. By the way, we did this in our homework, part of it. When we look at worksheet 3, I asked these questions. What is the sine of every pi over 3 angle? What is the cosine of every pi over 3? What is the tangent of every pi over 3? So we've really already done this. Let's relate it to our little chart here. Here's pi over 3. The sine is radical 3 over 2. The cosine is 1/2. The tangent, and we'll remind ourselves how we got that, is radical 3. Remember, tangent is sine over cosine. So if I take radical 3 over 2 and divide it by 1/2, this is what we were doing in our homework. We'll flip and multiply. My 2's cancel, and I'm left with radical 3 over 1. Same thing here. I'm going to write this down. Sine theta over cosine theta. If I take this box and divide by this box, I get 1. And if I take this box and divide by this box, I had you do this a million times in your homework, you get radical 3 over 3. When I say a million times, I'm referring to worksheet number 2. When I asked you to do 13, 14, and 15, I asked you to take 1/2 and divide by radical 3 over 2. And then I changed the denominators to say it doesn't matter what the denominators are. Okay? All right. This takes our unit circle and just pairs it down. Okay? Some angles, though, are not 30, 45, and 60s. They are on the axis, or angles that I say hit the post. The coordinates here, we just know. 1, 0, 0, 1, negative 1, 0, 0, negative 1. Okay? All right. So we're going to come back to this, and we'll talk about how to create that a little bit quicker, okay? But we're going to continue on here. So, unlike right triangle trigonometry, trig values may be negative, right? We saw that, right? If we said the sine is the y coordinate, well, here the y coordinate is negative. So the sine of 7 pi over 6 will be negative 1/2. So I'd like to start with which quadrants am I in if sine is positive? Remember, sine is the y coordinate, so I'm asking when is the y coordinate positive? Well, that's going to happen in quadrants 1 and 2, right? I go over and up, or I go over and up. What about cosine being positive? If cosine is positive, that means the x coordinate is positive. That means I'm going over and then up or down. So that puts me in 1 or 4. If tangent is positive, that means y divided by x is positive. Well, let's think about this. In the first quadrant, x and y are positive. So a positive divided by a positive is positive. In the second quadrant, the x is negative and the y is positive. So when I divide a positive by a negative, I do not get a positive. When I go into third quadrant, x is negative and y is negative. Oh, a negative divided by a negative is a positive. And if I go into the fourth quadrant, x is positive and y is negative. So a negative divided by a positive is a negative. Okay. So notice they are all positive in quadrant 1. Okay. But the only time I saw quadrant 2 was for sine. So sine is the only thing positive in quadrant 2, which means everything else is negative. The only time I saw 3 was with tangent. So tangent is positive in quadrant 3. And the only time we saw quadrant 4 is for cosine. Okay. So how can we remember what's positive where? Well, all of them are positive here. The sine is positive, then the tangent is positive, then the cosine is positive. So going in order from quadrant 1, 2, 3, then 4, all students take calculus. In quadrant 1, they're all positive.
Interruption. The English department meeting is now starting.
In quadrant 2, sine is positive. In quadrant 3, tangent is positive. And in quadrant 4, cosine is positive. Okay. All right. So, to find a trig value for any angle in the unit circle without actually pulling out and using the entire circle, we need to know the answer to 2 questions. In which quadrant does our angle lie? Because that's going to tell us if our answer is positive or negative. And what is the reference angle? That's going to give us the value of our answer. I'll explain when we flip over the page. Okay. All right. So what I've gone ahead and done is I've gone ahead and just taken this chart here and recopied it here so that I don't have to keep flipping my notes over. Okay. All right. So here we go. It says find the exact value without using your unit circle. Using this, just not the big circle. So they want the sine of 2 pi over 3. 2 pi over 3. First of all, this reference angle is pi over 3, right? Pi over 3 says take pi, which is half the circle, and divide it into thirds. I want 2 of them. 1, 2. So I'm in the second quadrant. Sine in the second quadrant is positive. Okay, that's going to tell me the sine of my answer. Now I need to know the reference angle. My reference angle is this slice here, which is pi over 3, right? 2 pi over 3. My reference angle is pi over 3. So the sine of any pi over 3 angle is radical 3 over 2. Okay. Which we could check. We could go to our unit circle go find 2 pi over 3, which is here, and sine what's the y coordinate? Well, there it is. It's positive radical 3 over 2. Okay. But this system is going to allow us to not have to draw and write the entire unit circle. Let's talk about the next one, cosine of 5 pi over 4. First of all, the cosine of any pi over 4 is radical 2 over 2. I just need to know if it's positive or negative. Pi over 4 says take pi and cut it into 4 equal pieces. 1, 2, 3, 4. Well, let's go ahead and do the same thing on the bottom. I want 5 slices, starting at 0. 1, 2, 3, 4, 5. That puts me in quadrant 3. And in quadrant 3, the only thing that's positive is tangent. So cosine is negative. Okay. All right. Let's take a look at the third one. Now I'm in degrees. The tangent of 210. First of all, we need to know where is 210. Well, going around halfway is 180. I need to go 30 more degrees to get to 210. So I'm in the third quadrant. Tangent is positive in the third quadrant. Now I just need to know my reference angle, right? To get to 210, this is 30 degrees. So I want the tangent of 30 degrees, which is radical 3 over 3. All of these we could check on a calculator. Let's look at this one, the cosine of negative pi over 3. Well, the cosine of any pi over 3 angle is 1/2. I just need to know if the answer is going to be positive or negative. Pi over 3 says take pi and cut it into 3 equal pieces. So I did that on top and bottom. Negative one of them says drop down 1. So I'm in quadrant 4. Cosine is positive in quadrant 4. Okay. Let's keep going. Let's look at the tangent of negative 5 pi over 4. The tangent of any pi over 4 angle is 1. I just need to know if it's positive or negative. So let's take pi, cut it into 4 pieces. I guess I could have used my picture from the last one. That's okay. And I want to go backwards 5 slices. 1, 2, 3, 4, 5. That puts me in quadrant 2. Tangent is negative in quadrant 2 because the only thing that's positive there is sine. Okay. Let's look at the sine of 4 pi. Pi is half the circle, right? So there's, if this is my y-axis, there's 1 pi, 2 pi, 3 pi, 4 pi. 4 pi is really the same as 0. It's really saying, what's the sine of 0? Well, 0's not in here, is it? I'm going to flip back over. This is when this chart comes into play. I'm here. They want the sine here. And remember, sine is the y-coordinate. Flip back over. I'll go ahead and just write the coordinates down here. So I want the y-coordinate at the point 1, 0. Well, the y-coordinate is 0. Okay. Good. Let's look at this one. The tangent of 270. 270 degrees is down here. It's another angle that hits the post. Right? So the coordinates here are 0, negative 1. How do we find tangent? It's the y-coordinate divided by the x-coordinate. The y is negative 1, the x is 0. Negative 1 divided by 0?
Aiden Durand, if you are in the building, please come to the front office. Aiden Durand.
Sorry. So these two angles don't come from the chart because these are angles that are inside the quadrant, and these two angles are on the axis. Okay, so the y-coordinate divided by the x-coordinate, we can't divide by 0, so this is undefined. By the way, you type that in a calculator, it'll tell you that. Let's grab one real quick. Now, if I'm in degrees, I better make sure my calculator is in degrees, which it is. And I'm going to type in the tangent of 270, and it says error, right? It's undefined. Okay. All right, last one. The cosine of negative 225 degrees. So 225 is bigger than 180. Right, so I'm going backwards 180, and I'm going to go a little bit farther, not quite to negative 270. So here's negative 225, here's negative 180. I'm in the second quadrant, and cosine is negative in the second quadrant. I need to know the reference angle. How far apart are these angles? 225 minus 180 is 45. By the way, it will always be one of these. The cosine of any 45-degree angle is radical 2 over 2. Okay? So, this chart right here is super helpful. How do we come up with this quickly? That's what we're going to finish with. Okay? So, without using our unit circle to make our chart, we get a 3x3 box. Give yourself plenty of room. We're going to go sine, cosine, tangent on the outside. Smallest angle to biggest angle. So 30 degrees, 45 degrees, 60 degrees. 30 degrees is pi over 6. 60 degrees is pi over 3. You see how I switched the 6 and the 3? 45 degrees is pi over 4. They both have a 4 in it. Okay. So let's fill in the chart. Leave room for a fraction, but you're going to count up 1, 2, 3, and then you're going to count backwards 3, 2, 1. So we go 1, 2, 3, 3, 2, 1. I want you to take the square root of all of these numbers. The square root of 1 is 1. We don't know the square root of 2, and we don't know the square root of 3. And the square root of 1 is 1. So we did 1, 2, 3, 3, 2, 1. We take the square root of all of those, and we're going to divide them all by 2. And look at that. There's our numbers that we came up with from our unit circle. Okay. Now we just need to get that last row. How did we get the last row when we did it on the front? We said to get tangent, you're going to do this number divided by this number. And if we do that every time, I'm telling you, you're just not going to be very happy. So I highly recommend you memorize it. It's easy to get the middle one. Okay? And just like we did our angles from smallest to largest, these numbers just in this row go from smallest to largest. This, would you agree, is smaller than this one because we've divided it by 3? So it goes the smallest piece and then the biggest piece. I highly recommend you just memorize that bottom row. That way it saves you a lot of time.